Guys, well, good morning, good afternoon, good evening, where you are around the world. My name is Mike Aubrey. I'm with the Wildlife Conservation UAV Challenge, and with me today we have an exciting webcast for you. So, partner in crime here, Princess Aaliyah. Hello, welcome. Also heading up this webcast. Our guests today are from NASA, which is awesome. So, I'd like to introduce Mark Moore, who's going to be the primary presenter today, and Rob McDonald. So Mark, actually, he's been with NASA for 29 years, so he goes way back on this. His background is aeronautical engineering. His master's degree is out of Stanford University. He's currently pursuing a PhD at Georgia Tech, so you have a brain on the phone here. His research focus is powerlifted vehicles, and so he has a lot of robotics background. And he's done a lot of stuff just throughout his own technical publication background, actually promoting the future vision of distributed and on-demand aviation, which is actually what a lot of this talk is about, talking about. Today he's going to be focusing in on a product actually called, it's, as you can see on the screen there, Open Vehicle, or the Open VSP product. And it's, well, I'll let you guys see it. My team's actually used it as well, so this is going to be really exciting. I was actually joking before the webcast that there's what we used it for and then what it actually does. So I think this is going to be a really educational and exciting webcast. So Mark and Rob, thank you so much for joining us today. Rob, do you want to give a bio about what your background as well? I think we're still working on his microphone too. So the way we're going to do the flow today, we're going to do it pretty similar to last time. Princess Aaliyah has some quick announcements for you, and there's some exciting ones, and then we'll jump into the meat of the presentation. So Princess Aaliyah, what's going on in the world?
Hey, thanks again for being our great host that you are. And
You're too
Mark
kind.
and Rob, thank you so much for doing this presentation for us. It's exciting. We're actually getting a lot of interest on our webinars, which is really exciting. And as you can see, every week we try to bring something that's really going to be a very helpful tool for you. And I finally was able to get our past webinars up on YouTube. So if you go to our YouTube channel, which is wcUAVc, you will be able to have access to all the previous webinars that we've done as well. Once again, I do want to make the announcement for the critical design review. The date has been extended. A lot of teams actually asked for the extension, as well as the fact that we didn't get done doing the reviews for the actual design concept until the middle of this month. So if your team has not received your reviews yet, please send me an email at aliyah@wc uavc.com and let me know that you have not received it, and make sure that you do get your team's review. Um, so those are just a quick upcoming things that are on our plate. Nothing major today, so I'm going to give the floor to Mark and Rob to take over from here. And if there's anything else that I need to follow up, I'll make sure to do that at the end. And thank you again, Mike, for participating and hosting this with me, and Mark and Rob for the presentation today.
Great, thank you very much. Okay, Rob, I want to invite you to at any time jump in and make your comments. Hopefully, we've got your mic working. You there? Well, he'll jump in at some time,
Yeah,
knowing him. He's
he'll
not
often.
shy. So, I'm going to talk to you about a really cool tool. At least I'm really excited about it. I'm not a tool developer. I have been doing conceptual design of advanced aircraft my entire career, over 30 years at NASA. So what I really care about is a fast, easy to use geometry tool that can quickly let me model in three-dimensional dimensions and visualize advanced concepts, package things together, quickly do analyses and understand how well it works, and really be able to explore all sorts of new concepts. And frankly, in the past, when I've had to do that in CAD before this tool didn't work, CAD really stifled my creativity because it's really fantastic for manufacturing, but it's not so good for quickly, essentially sketching on the back of a napkin in 3 dimensions and getting a concept visualized. So that's what we're going to talk to you about today. It's called OpenVSP. You can download it. It's free. It's open source. You can use the source. It's all there. And let's get into what it can do for you. So there's really three different stages to design: conceptual, preliminary, and detailed. I've spent my entire career working on the conceptual design side. That is, exploring very, very large design spaces with new concepts, performing sensitivity studies, optimizations to try to lock in what the vehicle should look like, what should that outer mold line shape be in order to best perform a specific mission and a desired capability. Now, after that, you get into increasing stages of detail where you add more and more characteristics and fidelity to that model. Now, eventually, definitely, yes, you're going to want to get to CAD. If you're going to eventually build a very detailed vehicle or design a 737, yeah, at some point you're going to want to transfer to a really good CAD program because it's great at manufacturing. But really, the whole mindset with this effort is we don't want to burden the front end conceptual exploration with what the back end needs. So they're very very different needs between the front and back end, and I'll describe this with an analogy, and that is sculpting. Just imagine if you had this big block of marble and you got out your finest pick to start working. It would take you forever to get down to your statue. So you start with a big sledgehammer and power saw, and you whack away the big pieces. Then you go to a slightly finer grade of chisel, but still taking away big chunks of that marble until you really got it honed in and you know what it basically has to be. And then you can use your really fine tools to pretty it up and finalize it. Design is exactly the same way. You want to use the right tool at the right time to do the right work. So when we talk about geometry, you got to realize our objective is to analyze these concepts, right? It's to figure out how well they're going to work compared to everything else that's out there. Well, it's really important to understand that geometry is the core and starting place for all analysis. And it's an interesting, if you think about geometry, everything is an approximation of reality. And if you look at those three different approximations of a circle, right? They're different. They're different approximations. They're for different purposes, but that really gets to a really important point when you start talking about geometric modeling, and that is what you want to be able to do for one analysis is not necessarily what you want for another analysis. So what we have is this common ability to create this three-dimensional shape and then export all sorts of different metageometries. And let me show you some examples of that. For instance, when you're essentially rendering a 3D sketch of your vehicle, very useful to just look at it in a wireframe. If you're going to send that to a vortex lattice method, well, then you want a flat plate model. If you're going to export that to star CCM or any one of the other CFD codes, that's your favorite code, then you're going to want a quality surface mesh. If you're going to do finite element analysis, then you're going to want a structural mesh. So there's really, even though you have this common basic 3D model, this watertight model, you really want the capability to be able to export many different versions of that geometry, different meta models that represent what you're trying to analyze. And that's very important when it comes to VSP. And so Rob and Cal Poly have been just doing an incredible job over the last couple of years taking our initial parametric geometry core modeler and essentially creating what they call degenerate geometry models, where on the left-hand side you can see what a three-dimensional model that you would create in OpenVSP. That is specifically a Cirrus SR22 that I modeled up. But when you want to analyze that in a rapid, flat plate vortex lattice method, then what you really want that analysis method to see is not that wireframe on the left, but the degenerate flat plate model that you see on the right. And they're very, very different geometry representations of the same core vehicle. So this is a very important capability that Rob has been working really hard to implement in this latest version. So it's not just a flat plate model, degenerate model that you can get, but all sorts of different degenerate models depending where you're trying to send this geometry in terms of analysis. So again, getting back to this comparison of why you might choose to use OpenVSP. Again, I've been working at NASA for 30 years. When I first started working at NASA, we input all geometry as text. And you really had no idea what you were modeling, but you had different parametric inputs for span, chord, and you ran it through the analysis and you hoped that you got everything right because you weren't even visualizing the geometry. Well, as PCs started to become more powerful, there was this quick trend to go to computer-aided design. And again, that originated for manufacturing purposes. So it's incredibly good at being able to create a solid model of any shape. Well, the fact is, for conceptual design, we really don't need to create any shape. Basically, we need to be able to create round things and flat things and put them together in different combinations. So we wanted to find this sweet spot where we could give up some of the complexity that CAD inherently creates by being able to model anything, but instead be able to have this ease of use and rapidity in putting together these 3D models parametrically the way that we used to do it in text, but be able to represent that geometry visually and see what we're getting. So I'm on slide 8 now, where you actually see what you'd see if you opened up OpenVSP. And this is a model of the Bell Eagle Eye, which is a UAV tilt rotor. And you can see that we have it in wireframe mode, and you can see the internal packaging and the outer mold lines. In the geometry browser, just to the right of the visualization window, you can see that it's made up of all these different components. And then if you look to the right, you can see, specifically looking at the wing component, that it's made up of essentially different parametric inputs. So instead of defining that wing as you would in CAD with a whole bunch of points or essentially extruding an airfoil shape, you just input the span, the tip chord, the root chord, and can have different driver groups depending on whether you want to specify aspect ratio, taper ratio, and it's very, very easy, and you can create a wing in a few seconds. And even my high school student son finds it very easy to use and create three-dimensional models very, very rapidly. So inherently with OpenVSP, we're trying to get away from the complexity and burden of CAD by being able to use parametric inputs to quickly create three-dimensional solid models. So what are some of the attributes of OpenVSP? First of all, the core of it is that it's parametric. Everything is designed parametrically. That's really important when you start to understand what you're going to use that geometry for. In conceptual design, we don't know what the vehicle is supposed to look like. So we want to investigate this design space parametrically. We want to do sensitivity studies, optimizations, And the way that you do those sensitivities and optimizations is by defining different parameters that you're going to run different values. You can't run a sensitivity off a cloud of points, which is what you have in CAD. So the OpenVSP is incredibly flexible. It's real-time interactive. It also has the capability to be batch operable so that you can do sweeps without using the interactive visualizer. It's also highly portable. We have it working on Windows, Mac, Unix, and several other operating systems. It is a community, so very much we're trying to engage, all the different users collaboratively. And so, for instance, other users have created different versions of it that we don't even inherently support because we don't use it at NASA. Um, Going on, so what can OpenVSP do for you? I've shown two examples, a UAV on the left and the Mars Flyer on the right. For the Mars Flyer project, it was the hardest part of that design effort was the packaging. That is, the entire vehicle had to fold up and fit into an aeroshell, this little trash can, and it made for a very complex geometry problem, which OpenVSP handled wonderfully because we could look at the internal packaging. So these are directly pictures from OpenVSP. Likewise, with the UAV, you can model up all these internal components, see how it's going to fit, have this outer mold line where you can quickly analyze and see what the induced drag and parasite drag is and how everything's going to fit together. So directly you can compute wetted areas and volumes from OpenVSP very, very accurately. Also, we have the ability to export stereolithography files. So we can directly create a wind tunnel model, a small wind tunnel model, or desktop models such as you see. All these vehicles were created from OpenVSP geometries. Also, often we need to be able to create visualizations of our concepts in order to get them funded or to get people interested in them. So all of these models that you're seeing here were first created in OpenVSP and then exported through Rhino. And also, one of the neat things that Rob has just done is he's created a step output. So we'll be able to directly transfer to other CAD programs and visualization programs through STEP, which we've only been able to do with Rhino 3DM files in the past. But essentially, you're seeing one of the concepts that we created in VSP exported to Maya, and the animators then prettied it up and essentially added rotating imagery. But I like to show as a representation of this one of the studies that I did a couple of years ago where we had to design this UAV that was going to be able to be launched from an Ohio-class submarine. So we literally modeled up the Ohio-class submarine in OpenVSP. We modeled up that capsule that you see on the lower left in OpenVSP, and the UAV that you see on the lower right in OpenVSP. So it's a very, very adaptable geometry engine for creating even more than aircraft and being able to quickly get to other programs that can help you visualize these concepts in a really pretty way. But I don't want to mislead you. We're not trying to burden OpenVSP with the ability to do it all. We don't want to be able to do all the pretty graphics in OpenVSP. We'd rather have it be easier to use than have it do an awesome job of texture mapping, which Rhino does. So as long as we can export OpenVSP models to these other tools that are going to always be more capable, but also much harder to use and expensive. So again, it's having the right tool and using it at the right time. And OpenVSP is the starting point for, I believe, all your geometry needs in aircraft design. So here I'm showing, not just the ability to get to pretty pictures on slide 13, but being able to get to the core of what we want to do, and that is get to aero propulsive analyses. So we've taken OpenVSP models to vortex lattice. We're just spooling up a distributed vortex element effort through Georgia Tech, through panel methods such as CB Aero, Euler methods such as CART3D, and the full Navier-Stokes solutions. And you're seeing some of those are results of different concepts. One of the really exciting things that is just happening now that Rob and NASA Ames are doing together is they've developed a brand new open vortex lattice code that also couples in actuator disks. So if you look at that picture in the middle, that is a picture of the new VSP Aero that in version 3 will be directly embedded in OpenVSP. And the neat thing is you can see that you're able to capture with a really fast and easy to get to aero propulsive analysis, even the propeller swirl effects. And so I'll say a little bit more about the new VSP Aero. Again, vortex lattice is neat because it's a really fast method that you can actually embed in your optimization loop and just run hundreds or thousands of cases as you vary the span, aspect ratio, and different parameters of the wing. But now you can also be varying the propulsion characteristics and do crazy things like we're investigating of having all these little propellers distributed across the entire leading edge of the wing, and for instance see the different swirl effects that are taking place and changing that span-wise load distribution that you're seeing on the lower right. So it's really exciting that we're able to get to much better analyses much earlier on in the conceptual analysis, and that's the whole power and beauty of OpenVSP. Another thing that we're just starting to spool up through the University of Texas at Austin, through a professor, Armin Chaput, is the ability to analyze the structure. So he's taken a degenerate version of our OpenVSP model and is able to model up the wing box and then directly take that to calculus and do a finite element analysis. So really exciting that not only are we able to get to aerodynamic analysis, but now we're able to get to the wing structural analysis very, very quickly and very, very easily. So if you go to the OpenVSP website, which I invite you to do, you'll see on the left that's the opening page. And one of the neat things that's included with the OpenVSP website is on the right, and that is a Hangar. So right now there's about 150 different models, and we invite all the different users in the community to upload and download models from this central repository. Some of the models are really good. Some of them are done by students who don't know what they're doing, and they're pretty pathetic. That's the beauty. That's the power of a community, right? You get what you get, and that's one of the neat things is that Rob has implemented is, this this ability to rate the models. So the users and the individual person who put it together can actually say, okay, did I just do this as a quick and dirty crappy model, or did I put a lot of effort into this? And it can help guide you as you look at the different models. Just closing up, because I want to get to actually showing what OpenVSP is and can do. I just wanted to share, we track the statistics of its use, and already we're at over 50,000 downloads. So this is very much getting out there. One of the wonderful opportunities that Rob provides every year is for us to get together as a user community at Cal Poly San Luis Obispo out in California in the summer. It's a really beautiful place, and it's a perfect time of the year to go out there. So I invite anybody who's interested in learning more about this. Essentially, you could come on the first day as someone never having used OpenVSP, and by the end of the 2.5 days, you could come out as an absolute power user. So I invite you to consider coming out. It's a nominal fee of, I think, $150 to show up, which just covers the food and beverages for those 2.5 days. It's a really fun experience, and I hope you'll consider coming. In conclusion, essentially, I've tried to show you that OpenVSP is specifically and was created as a purpose-built conceptual geometry modeler for parametric conceptual design. It is very easy to use. I have kids in high school use it all the time without difficulty. I give it to my summer students, and within a day or two, they are making beautiful models. It is not like CAD, which you can spend 3 months and you're still barely a baby user. It's very flexible, it's real-time interactive, it's batch operable, and it's portable across many different operating systems. We use it exclusively as our geometry tool in conceptual design, and take it even into stages of very detailed aeropropulsive design with Fun3D and other very capable CFD tools. Recent developments, if you used OpenVSP a couple years ago, it wasn't nearly as good as it is today or as wonderful as it will be in the August version 3 release. An incredible amount of work has gone into this version 3. It's essentially been completely rewritten as an API so that it can be used as a core graphics geometry engine from other programs. Best of all, OpenVSP is free. Even the source is available. You can't beat that, right? So I'm going to jump out of this, and while I get into OpenVSP, I'm going to see if Rob's mic is working and if he wants to make a few comments.
Can you guys hear me now?
Yeah. Hey, Rob.
Okay. Well, I'm not sure what all to say since Mark did a good job of pretty much covering things. Just a little background on myself. I'm on the faculty at Cal Poly in San Luis Obispo, and I've been working this problem of geometry for conceptual design for, the last dozen years or so, one way or the other, and been working closely with NASA throughout that process. And like I said, Mark covered it pretty well. I'll just be here for any questions or anything else that pops up.
Okay, so you just saw me double-click on OpenVSP on my Windows laptop. And so this is what you come up with. And essentially, it's a very simple browser. So I think we're 30 minutes into this. How long should I go, Aaliyah?
I can speak. You guys should go till you're done.
Okay.
Yes, thank you.
In finite terms, the goal is to be wrapping up at the top of the hour.
Okay.
So I guess it'll be the bottom of the hour.
So one
I
of the
was
things we wanted to make sure we do is leave some room for questions. But maybe Mike, as the questions come in within the next 5 minutes, we could start asking Rob and Mark the questions from the teams.
Sure
Yeah.
can.
So I'll spend about 10 or 15 minutes
Okay.
then just quickly showing what OpenVSP can do. So essentially you see across the top the different main commands. File, you can create a new, you can open an existing, you can save, you can import, you can export. I'll show some of those capabilities. Actually, let's just go ahead and jump in and open something that I'm working on right now, which is the crazy, distributed electric propulsion. So you're seeing I'm going to go ahead and, so here's the geometry browser, which automatically comes up. I'm going to select all the components because you can see a bunch of different components, especially lots of props and hubs and motors. I'm going to select them all. I'm going to go into shaded view, and then you can see that now it's, instead of a wireframe, it's shaded. I can zoom, look up close. I can rotate. You can see that I've modeled up the wing and a flap at a 40 degrees. I have a bunch of props. One of the neat things is built into OpenVSP are parent-child relations. So, actually I can close up all these motors, props, or I can open it up. I can move them, and notice they all move together because they're all children of that wing parent. So I can go in and let's go ahead and change the characteristics. I'm running out of screen space because I've got these other things here. But again, you can see the general characteristics of the wing include what type of material it's made out of. I can make it translucent, see-through, golden glass. I can make it, whatever color I want. This is attaching to the parent, to the children. I can change, if I go back to wireframe, I can change the tessellation, make it more coarse or less coarse. In terms of where it's located or what the rotation angle is, I can control that here. You can control the symmetry here. So really basic things. It's well laid out. Here's so let me get into the section characteristics. Again, this is called a multi-section wing component. And there's essentially a few different component types that we tend to use over and over. So with this component, it's defined essentially by these parameters: aspect ratio, taper ratio, wing area, span, tip chord, root chord. And you'll notice that, for instance, three of the six are able to be changed. And the other ones I can't change because they're moving automatically. And that's what we call driver group. So sometimes you may want to define the wing with the span, the tip chord, and the root chord. Other times you may want to define it by the aspect ratio, taper ratio, and area. So essentially it gives you the ability to define it with different parameters, whichever you choose. You can quickly change the sweep depending on which section you're working on. Here's the section ID. So you notice right now I'm working on this section that's boxed in. If I change to the next section, you can see now that this section is boxed in, and so if I change that sweep, oops, it's that little section, sorry. There, now I'm working on this section here, see? So if I change that sweep, just a simple parameter change. If I go to the next section, this is what I meant by multi-section wing. It's made up of 4 different sections. I can now change this sweep. I can go to a negative sweep. So very quickly and easily, you can fundamentally change the parameters that are defining the wing very, very quickly. I can change the dihedral, and I can read in any airfoil. There's also built into OpenVSP, for instance, 6 series, biconvex, all the NASA 4 series. If you do that, then essentially all you have to do is specify actually I'll go to the 6 series so you can see. Then all of these become able to change. I just specify the ideal CL, the 6 series type, and the thickness, and very easily I can change all the characteristics associated with this wing. Also, I can just read in an arbitrary airfoil file from your favorite place, such as the University of Illinois. So this gives you a basic idea of what you can do with it. Again, with the viewer, I can have one window. I can have 4 different views. You can have 2 different views. There's just a lot of different choices. I can throw in a background. For instance, let's put in a pretty sky picture. Just very, very easy. Actually, let me go back. Bring in the background again. So very quick and easy to create 3D models and even a rapid rendering. Let me jump into a different model. Since pretty much everyone here is interested in UAVs, let's actually I'll jump into this one. This is a UAV that let me get rid of that distracting background and actually just oops, sorry. There we go. So this is actually a UAV that we've just built at the 55-pound scale as a small UAS system. And again, let me select all the components, shade them, so you can have a look at them. Again, it's made up of all these different components. If I click on one, you can see it outlined. This specific UAV is designed as a vertical takeoff and landing aircraft. So you can see it has a pivoting wing, which again you're able to model up in VSP to test the articulation with all those components as children of this main parent, which is the pivot. Also, the tail pivots and provides a really, really robust vertical takeoff and landing control capability, which we're actually flight testing now. So, for instance, we did all the design of this starting from OpenVSP, exported to tools such as StarCM to do the aeropropulsive CFD, directly exported this to ProE, and then our CAD guys used that to then create even more refined models, which went directly to the fabrication of this vehicle. So, Rob, do you want to jump in and make any comments that I probably missed?
I think you're doing a pretty good job of walking through it, Mark. I think it might be a good time to see if anybody has any questions.
There are a couple questions, if you wanted. Within the first question that said in the realm of simulation, are there any plans to do sound analysis? I could read the question directly. Acoustic analysis.
So, by and large, the VSP philosophy is that we aren't experts in acoustics. We aren't experts in all the different tools for things like the aerodynamics or the propulsive analysis, and so we generally try not to build those tools into VSP. Instead, what we try to do is build connections that can feed those tools that the experts are already developing. So, depending on what phase of the acoustics process you're in, for example, if you're trying to look very directly at the aerodynamic noise generation and using a CFD tool to do that, then yes, already VSP can feed a large number of CFD tools, and you could use that process to start and calculate the aerodynamic noise of the configuration. On the other hand, if you're using a little bit higher level tool like an ANOP, which models noise sources and shielding and that sort of a thing, there isn't any current connection that I know of there, but the degenerate geometry capability that we're introducing would be a good one to then connect and feed ANOP so that it could do its shielding analysis of a high level concept. So I hope that answers the question.
So you showed a moment ago some of the airflow between some of the propellers. Was that generated within OpenVSP, or was that through a third-party program?
So
So right now there's right now those things are done with the math, the calculations of the aerodynamics are done
Mm-hmm.
with third-party programs, and that
Ah,
line is
okay.
going to be blurred a little bit in the future. As Mark mentioned, Dave Kinney at NASA Ames is developing a vortex lattice code that is going to be distributed with VSP, and so there's a case where we've got someone who is an expert at writing one of these tools who's writing one specifically to work really well with VSP, and we're going to try and have those distributed with one another and set up so that they work very easily and seamlessly together. So the one that you saw with a whole bunch of propellers and all of the twisting lines coming off of them, that was done with a prototype version of VSP Aero, which is being developed by Dave Kinney.
Okay. Okay. Let's go to another question here from. Actually, let's ask you guys a conceptual question. A lot of your examples have used a lot of propellers. One of our goals with what we're doing with our UAV is we're judged on time duration that we have it in the air. Um, uh, so obviously, if you use less propellers, you're using less power. Are there advantages to using more propellers?
definitely, but that's getting more to the conceptual design. So
Hmm.
actually, the concepts that I showed you are very unique vertical takeoff and landing aircraft, and that is, if you try to do a VTOL, you get into this big problem of power mismatch, and that is the power required to take off is fundamentally much greater, 4 to 5 times greater than what you need to cruise efficiently. So the concept that I showed you, actually, all of those propellers fold in cruise except for the ones out of the tip. And the ones out of the tip interact positively with the wing vortex to actually create an even lower induced drag. So we don't run all the propellers at cruise. We just use them and then fold them very simply in
Hmm.
order to be able to fly at a very, very high cruise efficiency, but also be able to have a reasonable takeoff power and disk loading at the takeoff condition. So you're getting into a really unique characteristic of distributed electric propulsion to be very adaptable to these strange missions where you need the vehicle to do more than one thing well. It has to be able to do several things well that are diametrically opposed requirements.
Thank you. I guess we'll go back to the question about the program itself. Is there a way to import airfoil coordinates of a particular airfoil via a DAT file? That's a .dat file into OpenVSP?
Absolutely. We currently support 3 or 4 airfoil file formats. We have our own format, but we also support uh, both of the file formats on, as Mark mentioned, the UIUC, the University of Illinois Urbana-Champaign
There we go.
airfoil database. And
Yeah.
so, and those files appear in 2 formats. There's a CLIG format and a Lednisser format, and we support both of those.
Okay. I love that. Let's see here, Edward. See if I can pull.
Well, while you're jumping to another question, let me just show a quick capability. Usually, well, here, I'll just go ahead and jump to it. So one of the neat and powerful features is you can create this, 3D geometry, solid geometry with internal components, and then VSP, you can go in and, for instance, calculate the wetted areas, and it'll figure out what's on the inside, what's on the outside, and then trim all those components that are on the inside, throw them out so that you can have the theoretical, the true wetted area, theoretical volume and true wetted volume buildup and see it for all the components and all the totals, and this can go then feed into your parametric, your parasite drag analysis. So very, very easily you can see how I just computed the wetted area and volume of this vehicle. That was quite complex, had a bunch of internal components to it.
Hmm. Let me give you another question. So Edward writes, he's excited that VSP is going to get aerodynamic analysis capability. Like that's actually something you just showed there. Can you discuss if it will be able to accurately model unconventional multi-surface configurations? The example he gives is joined wings and C-wings.
The VSP Aero program should have no problem with those kinds of things. It's based on vortex lattice theory, which means that it represents the lifting surfaces as thin surfaces, and it's going to have both a subsonic version with a Parametric correction, but also linearized supersonic flow. So it won't do, for example, high angle attack, separated flow. It won't do transonic flow, and we're still trying to figure out how good it when you do model a thick body like a fuselage, how good its modeling of that influence will be. But in terms of modeling wing-like shapes in arbitrary configurations, it'll do a fine job of that within the limits of vortex lattice theory.
Hmm. Next question. So Ron's asking, do you plan on adding power distribution in VSP to enable examination of electric aircraft parameters?
I'm not sure what you would have in mind. VSP is really at its core a geometry tool, and so right now we have no plans to add things like the calculation of the power required for flight or for climb, or the power required for various payloads, or a power distribution system where your batteries would go and what kind of a power bus you would have and how that power would get used. We see that as a different realm. On the other hand, as many of the aircraft that Mark has shown are inherently electric aircraft and use the flexibility of an electric transmission to allow you to distribute the generation of thrust all around the vehicle, which is a new degree of freedom and a great innovation in aircraft design. So in that sense, yes, you can do electric concepts that are unconventional, but the modeling of the volts and the amps isn't really a geometry problem.
Sure. I think, yeah, Ron, let us know. I think he was hinting at the power for versus distance thing. But yeah, Ron, clarify if you weren't. I think that answered the question. Edward has a follow-up question. Will the new Aero code be able to calculate wave drag if you put area ruling into the model?
VSP Aero itself doesn't, but we already have the ability to do the kind of slicing like a Harris wave drag code, like A-Wave, and I have code to then do the Edmonton-Lord calculation to turn that area distribution into a drag calculation. I just haven't. I don't have time right now to incorporate that, so we do have some pending contracts where that might get done in the next year or two, and certainly it's open source, so that would be an interesting thing to do. So I would expect that in the next year or two, yes, we will have a linearized wave drag calculation built into VSP.
All right. How about on examples of what people have used it for? Gert had a question asking if this tool has been used to design suborbital launch vehicles.
Absolutely. Well, suborbital, I know people have certainly used it to design all kinds of rockets and missiles, both that we'll just say most of the time fly horizontally and that most of the time fly vertically.
Sure.
And people have used it for reentry type capsules, space shuttle type configurations. People have used it to model the pilots and the equipment and the engines that go inside of these vehicles. People have used it to model LD3 standard cargo containers that your suitcases are carried in an airline.
Hmm.
Really, I've had students use it to model a Humvee because they were putting a Humvee inside a cargo airplane and they needed to have a representative shape of a Humvee. So really, there's a tremendous amount of creativity. It comes from the airplane world, but there's little reason that it should be limited to that. And quite frankly, I see one of the growth areas for our user base and for its application is really to be an easier way to model things for 3D printing. And one of the bottlenecks to home 3D printing right now is that CAD is such a pain. And if you want to create your own model, you have to deal with some very difficult tools that are very expensive and have a steep learning curve. And on the other hand, VSP can feed 3D printing very easily and directly, and can let you very quickly and creatively create just about anything you want.
Okay. I've got a couple questions around like kind of how to get started on there. I see there actually is a Get Started and a Learn More tab.
Yeah,
Um,
let me
do you
talk a
have
little bit.
could you point kind of where like the tutorial specifically around fuselage and then maybe airfoil design would be kind of there's some best tutorials there to kind of steer people
Yes,
towards?
exactly what I wanted to talk about. So I just opened up a browser and I'm on the openvsp.org website. This is what you'll see. Boom, you can download it just by clicking that button. But and you can jump to the VSP Hangar here, and you can see an ugly model that a student just loaded up of a car. Why he's modeling up that car, I don't know. But
Everything's beautiful.
let's see what somebody modeled up the Boeing Pelican. Just you never know what you're going to find.
We've
Um,
got people who model things from science fiction movies and put them up,
Mm.
and all kinds of things. Some people just play with it and do their first experiment and upload it. It's a little bit of the wild west of 3D models.
The beauty is in the journey.
well,
They're all
one of
beautiful.
the neat things is in the Hangar browser itself, you can rotate and see what you're going to get without
That's
having to
cool.
download it and open it. So right off the bat, you can get a pretty good idea of what you're going to get. So
Okay, so you
that's
got the
the
hanger.
Hangar. Um, One of the best places to get started is by clicking on the Get Started.
That is an
And
excellent place.
there you can download and install, or you can jump into the tutorial videos.
Okay.
And by watching these 6 or so videos, pretty much you will know what you're doing after an hour. And so essentially the first one just walks you through all the different menu items, how to modify the view, adding and modifying parts, a basic model of an airplane, and then specifically a Cessna being built up from
Oh, so there's your airfoil.
Boeing.
Yep.
Yeah,
And you add your
essentially.
fuselage. Yeah, that looks like a good one.
So one of the neat things is about that background is you can actually throw a 3D view into the background and build your 3D model right on top of it. So it's really is a very effective sketch pad. And then also getting to the features such as the mask properties and the arrow reference, and even the older VorView or Vortex Lattice method, which we're replacing with OpenVSP because we weren't allowed to distribute for lax, and we will have the rights to distribute the new VSP arrow. So these tutorials really will get you up. You'll be able to learn how to modify a fuselage, wing component, and do it all very easily.
Okay.
Also, there's a link to more information on the workshop. This is the third one that will be held. So again, I invite you to participate through that. What other questions?
So final question, I think, for the Open VSB, and then there are a couple questions actually for Princess Aaliyah about logistics about the competition itself. So final one on Open VSB. There's a question from Kavi um, asking, is it possible to import CAD geometry? So Maya, CATIA, SolidWorks, my program Fusion. Can you get 3D geometry into this program and use that?
So Mark will probably demo as I talk, but you can import discrete 3D models. So the easiest way to do that is probably an STL file.
Sure.
So if you have an STL triangle file from any source at all, you can import that and you can pull it in. And right now, with what Mark is demoing, is version 2 of VSP that
That makes
import.
sense. Yep. Yep.
that import just brings in the triangles themselves, and you can move it around and you can rotate it, but you can't do. It's not obviously parametric.
Yeah, that's a vicious STL too.
It is so, but the new version 3 has a pretty, I hope to be profound capability where you can read in an STL file, and then through an interactive process, iterative human in the loop, you can do a least squares fit of VSP components to that model. And so you can
Okay.
take a legacy file from, whether it comes from CAD or from a laser scan of a model or came out of somebody else's CFD analysis. Um, you'll be able to pull that in and come up with the best approximation of a VSP model uh, in parametric form that you can then start as a place for starting your design study. So you can take the airplane your company's already built, make a VSP model of it, and then look at doing a wing change or a fuselage stretch or something like that.
Okay. Cool. Yeah, that's very useful. Uh, Man, I wish that with this question, like there were like three different questions that just popped up on that, and like it's all in the final 3 minutes. That's a shame. Um, so if they wanted to do more, are you guys fine if they reached out to your emails and stuff? Are you guys available that way? Is that what's the best way to kind of ask questions?
I'm fine with that, but what I'd really encourage is for them to ask questions on the Google group that we have,
Ah, okay,
and that way, if other people have the same question, everyone can benefit from the
sure.
answer.
Okay. So your group, where is that Google group located? There we are, down at
At
the
the
bottom
bottom
there.
of the
Participate in the Google
website.
group. Okay. Okay. Awesome. Okay. Wonderful. We'll definitely continue the conversation there. For the final set of questions here, Princess Aaliyah, actually, there have been a couple questions about the competition itself. Um, Early on, there was could you clarify that our design requirements? Can you clarify that revised CDR
Yes.
deadline date?
Yeah, so the new CDR deadline date is June 30th. And the reason for that, as I had mentioned earlier, is because there are several teams that did ask for extension, as well as the fact that we weren't able to send your reviews back until like the middle of actually April or early week of April. So that's the reason why we've extended the time, but we've combined the June 30th date with also the flight readiness report as well. So both of those are due at the same time. And those changes have been made on the website. I don't know if you guys have had a chance to look at the new teams page, but we've got our map on there. It's a little bit easier to understand what's going on with the announcements and the changes in the webinars that are coming up. I know one of the questions that teams continuously ask is about the RFID tags. And voila, we finally have scheduled our RFID tags webinar for May 1st. So make
Yeah.
sure you stay tuned for that one and sign up for that one. It should be very, very helpful for you, for all the team members, of course. But next week, we actually have a follow up webinar for the solar panel application. So the next one is actually going to talk about the materials that are used in the application of the actual solar celled UAVs. So I think that would be a very helpful one for all the people that have an interest in looking at alternative energy solutions. We do have Scott, or LB, our South African director for the challenge, on. Hopefully, we should be able to get him to answer some of the questions that teams might have.
I think you just nailed the big one. Actually, I think we're good. There were questions around, there was a question asking around cost limitations on the aircraft.
Okay.
So actually, Bharat, it looks like you answered that one.
Yeah, I did.
So Bharat, just take a look at just the requirements of the just competing, and actually the cost numbers there are on kind of how point distribution is allocated. You'll get all the information right there.
Yeah.
The
Um,
jet,
ooh, where's that sound coming
so
from?
there's an ocean wave coming in.
Yes.
let's we'll go ahead and draw it to a close on that note then.
Is
So
that?
enjoy the beach and
Oh, hold on. Actually, LB, are you there?
I am. Can you hear me, Aria?
Yeah. Are you at
oh,
the
there you
beach?
are. Yeah, surf's up, dude.
Are you at the
No,
beach?
it's not me. I'm not at the beach, so
Oh,
I can't
Right.
take
okay.
credit for that one. I
Okay.
wish I was.
Okay. All right. Do you want to take a minute to talk about what's going on in South Africa for the teams for a quick update?
Yeah, absolutely. Kind of more of the same. We continue to get hit really hard. We were hit neighboring reserve. In fact, the one I spoke about last time we were all on was hit again, and they decimated the entire population of that reserve. So that reserve no longer has rhinos as of a day and a half ago. And the hard work continues, but it's hard to keep up. So we're making good progress, and we're really getting more and more excited about getting people here. Amakala is very excited, and preparations continue to get ready for that. So cyber canopy is in place. We'll have high-speed Wi-Fi by the time you all get down here, covering most of the reserve, along with multiple layers of RF to help out. And I had seen your question regarding RFID tags, Aaliyah, but without stealing the thunder for May 1st, I would go so far as to say that expect most RFID tags in the field applications to be running over 2.4 gigahertz.
Okay.
All right. Well, thank you so much, Elby. Appreciate the updates.
Well, it's very sombering and very exciting.
Yeah,
Um,
I know. How many rhinos were lost total?
Three again, 2 nights
Oh,
ago in the neighboring reserve. So that essentially is six within 3 weeks in that reserve, and two of those were pregnant. So
oh
you
no.
can kind of see where it goes. Um, but yeah, we have to remain optimistic, and a
yeah.
lot of advances on technology on this side. Now, if we can get some really good UAVs to join the fight, I think we'll be well on our way. So we're excited to get everyone down here.
All right. Thanks, Elby.
All right.
Appreciate the updates from South Africa.
Absolutely. Thank you, Elias.
Um,
Mark and Rob, thank you guys so very much for such a useful and helpful overview of VSP. I would like to add, though, that Mike is with Autodesk Fusion 360, and we've been working with him
don't worry
on the
about
CAD, and
it.
he's phenomenal. So if you guys need anybody that needs to take it and make it look pretty, he's the guy. So Mark, make sure you stay in touch with Mike about doing any CAD work for you guys.
All
I'll,
right.
yeah, I'll be reaching out to you guys. I think yeah, thanks, Aaliyah. I understand you guys is like the CAD pitch that it's an imposing thing, but yeah, I'll shoot some stuff your way. I think I've used OpenVSP with our stuff, so I think there's a lot of really good examples of where the handshake occurs, and I think you guys nailed a lot of the use cases. So it's that, yeah, I'll reach out.
Great. Thank you.
Yes, thank you. And we actually had a lot of people that are thanking us for such a
Yeah,
great webinar. Mike, I'm going to let you do our closing.
yeah. Uh, so yeah, on behalf of the entire competition, guys, thank you so much for taking the time to be with us. There's a lot of kudos coming your way here, and really terrific, exciting project, and we're looking forward to using it more in our competition. So thank you for showing it. For everyone else, have a great week, and we'll see you on the next one. And yeah, happy designing. Take care, guys.
Bye.
Bye.